Welcome to the deep dive. This is where we grab a whole stack of sources and really dig deep to pull out the absolute best bits of knowledge for you.
That's the plan.
And today we're setting off on a really fascinating journey. We're going deep into the hidden structure of how things actually work, especially in really complex places like healthcare.
That's right. We're diving into a brilliant piece of work called the Agile Network, a model to foster innovation, implementation, and diffusion in healthcare settings.
Ooh, sounds hefty.
It is, but it's fantastic. And we're zoning in on pages 27 through 48 specifically. That's the section they call the science of complex adaptive networks. It's really the core of their argument.
Okay.
And we absolutely have to give credit to the authors, Dr. Malaz Boustani, who's a distinguished professor over at Indiana University, and his colleagues Richard J. Holden, Goze Azar, and Craig A. Solid. Amazing work.
Absolutely. So our mission today, we want to unpack what makes these networks tick. How do they behave? What can they teach us about how information spreads, how change actually happens?
Look.
By the end of this, you should walk away understanding that even systems that look chaotic often have this hidden order. And maybe, just maybe, you'll see how to use these ideas in your own world. Okay, let's get into it.
Let's do it.
So the authors, they kick off page 27 saying something pretty profound. They argue that if you want to build something really ambitious, like this Great Lakes Practice Transformation Network they mentioned,
Yeah, a huge undertaking.
you can't just jump in blind. You absolutely need to understand how networks work first, especially these big social organizations, lots of different people, semi-autonomous, working together towards shared goals.
It sounds almost like common sense, but it's deeper than that. Think about a hospital or clinic. It's not just a lift of employees, right?
Right.
It's this unique mix. You've got the people, sure, but also their environment, the building, the tech, plus all these external pressures, regulations, funding, community needs. It's all interacting constantly.
So a change in one spot.
Ripples through everything. It's not isolated. And this isn't just, a nice idea. It's the science they use to build practical ways to make innovation happen and spread.
Okay, so how do they break down this science?
They pull from two really powerful fields. First, there's network science, and second, complexity science.
Network science, the nodes and links that connect us.
Okay, let's start with network science. You said it's been around a while.
Yeah, roughly a century. It's all about understanding social structures, how they form, how they change. The basics are pretty straightforward. You have individual members in a network, they call these nodes.
Nodes, got it.
And the interactions or connections between those nodes, those are the links.
Simple enough. Nodes and links.
Exactly. Think about, say, the U.S. air travel system. The cities or airports, those are your nodes.
Right.
And the flight routes connecting them, those are the links. Or think about the World Wide Web. Documents, websites, those are nodes.
And the hyperlinks are the links.
You got it. Now, the really key insight here, and it pops up again and again, is that the whole network working together achieves more than individuals could alone. The whole is greater than the sum of its parts.
Right, like in healthcare, one doctor can't do everything.
Precisely. A team of doctors, nurses, technicians, administrators working together in a coordinated network provides a much higher, more comprehensive level of care.
That makes total sense. And they use an example, right? Tommy's journey.
Yes, it's a great illustration. Tommy goes through the healthcare system, starting maybe at a mobile diagnostic unit, then primary care, specialists, maybe even long-term care.
It feels like separate visits to him, maybe.
It might feel that way, yeah. But his care is actually a function of this entire vast network, all these interconnected, interdependent caregivers. The quality depends on how well that whole system works together.
Okay, so it's not just about who is connected, but how they're connected.
Exactly. And they give us ways to measure this, to quantify it. That's where it gets really interesting for understanding how things like information or new practices spread. They lay it out in Table 2, page 31.
What kind of measures are we talking about?
Well, first, the obvious one. We're in the total number of nodes, just how many people are in the network.
Okay.
But then it gets more structural. They talk about degree, which is usually shown as K. That's just the number of links connected to any single node. How many connections does one person have?
So some people have more connections than others.
Definitely. And the nodes with the highest degree, those are called hubs. They're the super connectors, hugely important.
Hubs. Like the really well-known person in the office everyone goes to.
That's a perfect example. Then there's L, the total number of links in the whole network. And PK, which is the probability distribution of degrees, basically, it shows the pattern. How many nodes have just one link? How many have two? And so on. The shape of that distribution tells you a lot.
Wow. Okay. What else?
The clustering coefficient, this is cool. It measures how connected a node's neighbors are to each other.
Explain that a bit more.
Imagine two extremes. One is a super orderly network, like people standing in a grid, only connected to the person right next to them, high clustering locally, but maybe hard to get info across the whole grid quickly.
Got it.
The other extreme is a completely random network, connections everywhere, no real pattern, real social networks. They're usually somewhere in between. You get these tight clusters like teams or departments where people know each other well.
High clustering within the group.
Right. But you also get these crucial long-distance links that connect different clusters together. That's shown nicely in Figure 4 on page 33. These links are vital for spreading information across the whole network.
So the structure, how many links, who they connect to, whether there are clusters, that all dictates how fast information travels.
Absolutely. Shorter paths between any two nodes mean faster spread. If groups are really isolated, information gets stuck. It slows everything down.
This is fascinating.
And it leads to maybe the most critical concept from network science here, the power law distribution. They cover this on page 34, Figure 5.
Power law. What does that mean in practice?
It means that unlike a random network where connections might be sort of evenly spread out, real-world social networks don't look like that at all.
How do they look?
You typically find that most people, the vast majority of nodes, have only a few connections, maybe one or two.
Okay.
But then you have a few individuals who have tons of connections, and then even fewer who have an enormous number of connections. It's not a bell curve, it's heavily skewed, lots of people with few links, very few people with many links.
Right, those are the hubs again.
Exactly. The hubs dominate the connectivity. And this structure leads to something called a scale-free property. Page 34 again.
Scale-free. What does that tell us?
It means the basic shape, the functional form of the network stays the same, regardless of how big it gets. Whether it's 100 people or 10,000 people, you still see that power law distribution. You still see hubs.
Wow. How does that happen?
Through a process called preferential attachment. When a new person, a new node, joins the network, they don't just connect randomly.
They connect to the hubs.
They're much, much more likely to connect to the nodes that already have lots of connections, the existing hubs.
Okay, give me an example.
Think about a new doctor joining a hospital faculty. Are they going to randomly seek out another brand new hire? Probably not initially.
No, they'll probably connect with the department head or the chief of medicine or senior researchers.
Precisely. People who are already well-connected, influential, they connect to the hubs, and this process reinforces the structure. It keeps the network scale-free as it grows.
And these hubs, they must be incredibly important for spreading information then.
Incredibly powerful. Information given to a hub can spread through the network extremely quickly because they're connected to so many others who are then connected to others, and so on.
But there's a downside, right? You mentioned vulnerability.
Yes, that's the flip side. Scale-free networks are surprisingly robust if you randomly remove nodes. Losing a few people with only one or two connections doesn't really damage the overall structure much.
Okay.
But they are extremely vulnerable if you remove a hub, take out one of those super connected individuals, and the network can fragment. Information flow can be drastically disrupted.
That's a massive insight for any organization. Losing a key, well-connected person isn't just losing one person's productivity.
It can fundamentally damage the network's ability to function, communicate, and adapt. It changes everything.
Complexity science, the adaptive nature of systems.
Okay, that shift from random networks to scale-free, hub-driven networks is huge. Now, let's bring in the second piece. Complexity science. Page 36, they call healthcare organizations complex adaptive networks. What does adaptive add to the picture?
Adaptive is key. A complex adaptive network isn't static. It's open, it's dynamic, it's constantly changing, evolving.
They're not fixed in stone.
Not at all.
Yeah.
It's made up of all these interconnected individuals who are semi-autonomous, remember. They can learn, they interact, they self-organize, meaning patterns emerge without central control. And crucially, they co-evolve with their environment. They change in response to what's happening around them.
And adaptive means they learn from the past.
Yes, the network learns from experience. It modifies its connections, its behaviors, to try and survive better or perform better, especially when facing unpredictable stress or new challenges. Think of it like a living ecosystem, constantly adjusting.
So definitely not like a predictable machine. You can't just change one part and know exactly what will happen.
Exactly. And that's a major point the authors make on page 37. The old view of healthcare, treating it like a machine where you assume stability is normal, and you just need the right financial incentive or a new guideline to get a predictable improvement.
That just doesn't work.
It fundamentally misunderstands the system. These systems have nonlinear interactions. Small inputs can have huge unexpected effects. Or sometimes big inputs have almost no effect. Trying to impose rigid, top-down control often fails. It can even make things worse.
That explains so much. It explains why those big top-down initiatives sometimes just fizzle out. It's not just about having a good idea. It's about how it travels through this complex adaptive web.
Precisely. It's about diffusion within the network. And they break down what influences the interactions within these networks. Pages 38 to 40. It's fascinating.
Like what?
Well, first, just individual interactions. The day-to-day stuff. Doctors talking to patients, nurses collaborating, lab techs interacting, even connections with community groups outside the hospital walls. Every interaction is shaped by the specific situation, the environment, past experiences.
Okay, makes sense.
Second, the physical and social environment. Where things happen matters. A decision made in a formal boardroom feels very different and has different implications than a quick chat in the hallway or by a patient's bed.
And digital versus face-to-face.
Huge difference. Electronic health records, email, telehealth. They mediate interactions in totally different ways than talking in person.
Right. What else influences things?
Cultural dynamics. This is a big one. Things like seniority, who has more experience,
Yeah.
educational background, the different professional roles.
Like the classic doctor-nurse dynamic.
Exactly. That historical power differential can hugely impact how new ideas or innovations are accepted or resisted. They give a great example. Improving delirium recognition.
Yeah.
Often, interventions led by nurses are more successful. Why? Well, nurses generally spend more time with patients, directly observing them. And assessing brain status often falls more naturally within their scope of practice. The culture supports that pathway.
That really makes you think. What cultural undercurrents are affecting things in your own workplace? Things we don't even talk about.
It's a powerful question. Then, of course, you have the more obvious factors. Budgets, regulations, guidelines. These external rules definitely shape interactions and decisions.
Constraints we all live with.
And finally, knowledge and understanding. Everyone in the network brings their own unique background, their own experiences, their own way of interpreting information. So even with the same guideline, you'll still see variability in how it's applied.
So, putting it all together, changing behavior is incredibly complex. It's not just one thing. It's this whole web of forces.
A whole web. And the network's ability to adapt to respond to all these internal and external pressures relies completely on these intricate individual interactions. It's bottom-up as much as it's top-down.
Surging insights, the emergence of creativity and self-organization.
Okay, so now we bring network science and complexity science together. And what we find is that these complex adaptive networks naturally show those scale-free properties we talked about earlier.
Like the power law distribution, hubs.
Exactly. Power law degree distribution, those critical hubs, high local clustering within groups, but also those short global path links that connect everyone relatively quickly. These aren't just features added to the network. They seem to emerge from its complex adaptive nature.
And there's a researcher they mentioned, Philip Lambert, page 41. He identified some core characteristics.
Yes, Lambert points out three key things that all complex adaptive networks seem to share. First is emergence.
We've touched on that, the whole being greater than the sum of its parts.
Right. Individual bits interact, and suddenly new, often unpredictable properties or behaviors emerge at the level of the whole system. You can't predict the flocking behavior of birds just by studying one bird in isolation. Same idea here.
Okay, emergence. What's second?
The order-chaos dynamic. Now, this isn't chaos like total breakdown. It's more like a dynamic tension, a balancing act.
Between what?
Between extremes, maybe between sticking to established knowledge versus exploring totally new ideas, or between being very structured versus being very flexible, between introversion and extroversion in the network's communication patterns. This constant push-pull, operating near the edge of chaos, is actually where creativity and innovation thrive.
Interesting. So not too rigid, not too random, but in that dynamic middle ground.
Exactly. That's the fertile ground. And the third characteristic Lambert highlights is self-organization.
This seems crucial. It's not centrally controlled.
Fundamentally, no. Even if there's an official org chart, the real functioning network organizes itself. Patterns emerge from those local interactions. You get multiple hubs, not just one leader. You get that high local clustering in those short global paths. It finds its own operating structure, somewhere between perfect order and total randomness.
And what's amazing is you're saying creativity and innovation aren't things you force onto these networks.
They're natural results. They are emergent properties of networks that have that capacity for emergence and operate in that dynamic order chaos zone. The self-organizing structure, especially the clusters and short paths, actually makes the spread of new ideas more efficient.
So if you look at a hospital or any organization through this lens, it gives you a totally different way to understand how ideas spread, why some things catch on and others don't.
Completely different. And it reinforces that point about hubs. The network is tough against random losses.
But fragile if a key hub leaves,
Mm-hmm.
because their influence is just so disproportionate.
Exactly. Which leads back to that question for everyone listening. Who are the hubs in the networks you operate in? Professionally, personally, identifying them is the first step to understanding how influence and information really flow. Outro.
Wow. Okay, so we've really dug into the science here in network science with its nodes, links, and scale-free structures, and complexity science with its focus on adaptation, emergence, and self-organization.
Yeah, we've covered a lot of ground from those key pages, 27 to 48. Understanding these concepts is really fundamental. Helps you see how information and new ideas actually move through any human system.
It's not just healthcare, is it? It could be a school, a company, a community group.
Any group of interacting people. It's about seeing the hidden patterns, the dynamics that are always there, shaping how things happen.
Absolutely. And the authors, Dr. Boustani and his team, they really use this science to build a foundation, a new way of thinking about how innovation spreads. It's about seeing these systems as dynamic, learning entities where every single interaction matters.
So the big takeaway for you, the listener, this isn't just interesting theory. Knowing about hubs, power laws, emergence, self-organization, it's a practical lens. It helps you understand influence, why some changes stick and others don't, how resilient your own networks are.
Exactly. So here's something to think about. How can you start using these insights? How can you apply what we've talked about from network and complexity science to the networks you navigate every day, at work, in your community, even in your social life?
Yeah, think about identifying those hubs. Think about the links you create or strengthen.
And consider how sometimes maybe just small nudges, small changes in interactions could lead to really significant emergent shifts across the whole system.
Yeah.
How can you leverage those invisible threads to foster positive change and innovation? Something to mull over.